point 2 is rho 2 A2 V2 dt. It is negative force. It is negative as force and displacement are in opposite directions. The work done on the fluid due to pressure difference is W rho is equals to P1 A1 V1 dt minus P2 A2 V2 dt. Let it be equation number 1. The work done by the gravitational force on the fluid as the fluid flows from height h1 to h2 is Wg is equals to m into h1 minus h2 into g. Let it be equation number 2. Then the total work done on the fluid W is equals to Wp plus Wg. Then what equation we get? Work done W is equals to P1 A1 V1 dt minus P2 A2 V2 dt plus mg h1 minus mg h2. Let it be equation number 3. We are well on that according to work energy theorem, work done by net force is equals to change in kinetic energy. If we equate the equation number 3 with kinetic energy, then we get P1 A1 V1 dt minus P2 A2 V2 dt plus mg h1 minus mg h2 is equals to half m into V2 square minus V1 square. Let it be equation number 4. We are well on the value of mass m of the fluid. At point 1, mass of the fluid is rho 1 A1 V1 dt, and at point 2 the mass of the fluid is rho 2 A2 V2 dt. Let it be equation number 5. If we divide the equation 4 both sides by 5, then we get P1 by rho 1 minus P2 by rho 2 plus H1g minus H2g is equals to half into V2 square minus V1 square. Let it be equation number 6. For an incompressible fluid, we know that the density of the fluid at every point is same. Therefore, rho 1 is equals to rho 2 and it is equals to P. Then we get a equation P by rho plus Hg plus half V square is equals to constant. If we do LCM with rho, then we get P plus rho Hg plus half rho V square is equals to constant. It is nothing but the equation of Bernoulli's principle. Hence, we have proved Bernoulli's principle. Okay, Sweros, we already learnt the statement and proof of Bernoulli's principle. Okay, there are many examples which obey Bernoulli's principle. Let us discuss some. Okay, see Sweros, applications of Bernoulli's principle. One of its application is dynamic lift. Dynamic lift is the force that acts on a body by virtue of its motion through a fluid. And okay, Sweros, see this. It is ball and these are streamlines, and here the ball is moving without spin. So, the streamlines are equally distributed above and below the ball, and the velocity of air at both above and below the ball is same, and it results in zero pressure difference. So, there is no upward or downward force on the ball. See friends, here the ball is moving without spinning, and these are called streamlines. These streamlines are equally distributed above and below the ball. The velocity of air above and below the ball is same. It results in zero pressure difference. So, there is no upward or downward force on the ball. Okay, friends, see this. This is figure B. See here friends, this sign indicates the ball is moving with spin, and these are called streamlines. Observe friends, streamlines are crowded more above the ball than below, and the velocity of the air above the ball is large, v1 plus vr, and the velocity of the air below the ball is small, v minus vr, and these pressure differences cause dynamic lift. As a result, there is a net upward force on the ball. Okay friends, let us see next example. Dynamic lift acts on aeroplane wing. See friends, this is aeroplane, and when the aeroplane is take off, there is a difference in pressure. There is a pressure difference between upper and lower phases of aeroplane. This results in net upward force on the aeroplane. In the state of takeoff, because of this Bernoulli's principle, in the state of taking off, the aeroplane rises upwards. Okay friends, similarly, observe this. What is this? This is a hut. During a windstorm, when high velocity of winds blows over the roof of house, then the pressure at top of the house is decreases and pressure inside the house is increases. We are well known that pressure is inversely proportional to velocity. As the pressure is low, the velocity of air is more at top and less inside the house. As a result, dynamic lift occurs and the roof of the house will blown off. Okay friends, next example. We often see the kites. We often want to play with kites, right? Yes, this is also basing on Bernoulli's principle. And the uses of this liquid to clean our households and the uses of this instrument to decreases the fire is also based on Bernoulli's principle only. Okay friends, often we see that birds are flying in the sky, and this is also explained by using Bernoulli's principle. See friends, the flying of bird is also explained by using Bernoulli's principle. Okay friends, today we learnt about derivation of Bernoulli's principle and statement of Bernoulli's principle and the examples which obey Bernoulli's principle. Okay friends, before inviting you to ask me questions, I want to say the synopsis and the key points in this lesson. And the key points are, first one is statement of Bernoulli's theorem. And we know that the statement of Bernoulli's theorem is, when a non-viscous incompressible fluid flows steadily, the sum of pressure energy, kinetic energy and potential energy per unit volume of the fluid remains constant at all points in the path of the flow. And the mathematical formula is P plus rho g h plus half rho v square is equals to constant. It is nothing but Bernoulli's equation. Okay friends, today we learn the applications of Bernoulli's principle, right? And there are many examples in our daily life which obey Bernoulli's principle. Okay friends, in exam point of view, from this lesson we may get either a 4 marks question or a 2 marks question. And the 2 marks question is hello?
Hi, Sparrow.
Hi Sparrow, may I know your good name please?
Sparrow. Good afternoon.
Good afternoon Sparrow.
Hi, Sparrow. Good afternoon.
Good afternoon, Sphero. May
This
I
is
know
Monica from Ambedkar College, Khammam district.
Okay, friend. Do you have any doubt?
Yes, I want to ask one question.
Okay, ask me.
In Bernoulli equation,
Yes.
please explain how half rho v square is equals to kinetic energy per unit value.
Okay, Sphero. Good question. See, friends. Here we told that half rho v square is equals to kinetic energy per unit volume. Okay. To get kinetic energy, half rho v square into, it becomes this form, kinetic energy equals to half rho v square into v. Sphero, observe here v indicates velocity and here v indicates volume, and we are well known that the product of density into volume is equals to mass. Yes, instead of rho density and volume we can write m, then we get Ke is equals to half mv square, which is nothing but mathematical formula of kinetic energy. Okay, Sphero, is your doubt clear? Okay. Okay, and the 2 marks question is, mention 2 examples which obey Bernoulli's principle. And the 2 examples are, first one is the example what we do first, where air blown over the pieces of papers. And the second example is blowing off roof of a hut. And 4 marks question is, state and derive Bernoulli's principle, what we discussed in this class. Hello? Hello? Hello, good afternoon, Sphero.
Hello?
Good afternoon, Sphero.
You say na Bernoulli principle is constant. Why is this constant?
Sorry, Sphero, I can't understand your question. Okay, Sphero, and the 4 marks question is applications, explain the dynamic lift with examples. What we discussed in the previous examples. And these are the 3 questions which may come in exam point of view. Okay, Spheros, today we learnt about statement, proof, applications of Bernoulli's principle, and we can find many examples of Bernoulli's principle in our daily life. Okay, friends, see here, we already discussed about this figure A, what is figure A showing and what is figure B showing. This is very important question from this topic, and this question carries 4 marks. Okay, Spheros, today let us recall what we learned today. What we learned, and moreover I want to explain you one thing, Spheros. We take that mass m is equals to rho 1 a1 v1 dt, right? I want to explain how mass is equals to rho 1 a1 v1 dt. Let us see. Here m is equals to rho 1 a1 v1 dt. Rho means rho and v means a, and what is v1? v1 is volume. Okay, the v1 is volume. Sorry friends, this is work done. Sorry friends, this is work done. P1 A1 V1 dt. This is work done P1 A1 V1 dt, and we know that work done is equals to force into displacement. And what is the formula of force? From this equation P equals to F by A, we know that force equals to PA. So instead of PA, we can write F, and the product of V1 and dt is equals to displacement. S equals to V into dt. dt means time. Here we already discussed that we take t as dt. Then instead of V1 dt, we can write S. It is nothing but work done is equals to force into displacement. Okay, Sweros. Okay. First of all, I want to thank Secretary Sir, the beloved Secretary of our society, Dr. R.S. Praveen Kumar Garu, for providing us this great opportunity to teach as a teacher in the small age. And I want to convey my heartful thanks to the principal, staff and DCO of Khammam district and the principal and staff of Dr. B.R. Ambedkar Junior College, Khammam. Thank you, Sweros.